In this video, I will show you an example of Thevenin equivalent circuit. Thevenin equivalent circuit, that means I will replace a total circuit between two terminals with a voltage source of VTH and a series resistor RTH. Let's say this is our A terminal and this is our B terminal. Previously, between this A and B terminal, we have a very big circuit. If I can replace that circuit with a voltage source of VTH and RTH, that circuit will be our Thevenin equivalent circuit. Now in this circuit, we have to draw the Thevenin equivalent circuit across this A and B terminal. We have to draw Thevenin equivalent circuit. That means I have to calculate total Thevenin resistance RTH and the Thevenin voltage VTH. At first I will calculate Thevenin resistance RTH. When I will calculate Thevenin resistance RTH across this terminal and this terminal, therefore I will replace the current source with open circuit and this voltage source with a short circuit. To calculate RTH, replace voltage source with short circuit and current source with open circuit. See, I have replaced the current source with open circuit and the voltage source with a short circuit. Now what will be the total resistance? That will be denoted as RTH across this A and B terminal. You will see, with respect to this terminal and this terminal, we have to determine the resistance with respect to this terminal and this terminal. Now before find out RTH, look at this terminal and this terminal. You will see we will have total two resistances, 5 ohm and 25 ohm. They are connected in parallel across a short circuit. That means there will be no current flow through this 5 ohm and this 25 ohm resistor. That means I can discard this 5 ohm and 25 ohm resistor as they are connected across a short circuit. So after removing 5 ohm and 25 ohm, our new circuit will look like this. Now look at this terminal and this terminal. You will see this 20 ohm and this 40 ohm resistances will be connected in series. Therefore our RTH will be equal to this 40 ohm and this 20 ohm will give us a value of 60 ohm, and that will be connected in parallel with this 60 ohm. Therefore our RTH will be 60 ohm parallel 60 ohm, which will give us a value of 30 ohm. This will be our RTH. Here our RTH equal to 30 ohm. After calculating RTH, I will have to calculate VTH. Here I will have total two independent sources in this circuit, this 30 volt and this 1.5 ampere. Therefore I will use superposition theorem to calculate our VTH. So let's say at first I will keep this 30 volt source active. Therefore I will replace this current source with an open circuit. Okay, if I keep the 30 volt source active, I will replace the current source with an open circuit. There will be no current flow through this path. Now the voltage that will be dropped across this 60 ohm resistor, I will denote that voltage as VTH prime. See, this is the positive terminal of the voltage source, therefore the current will be entering in this direction. Therefore this terminal of this 60 ohm should be positive because current will be entering in this 60 ohm resistor from this direction. Therefore this terminal should be positive and this terminal should be negative. Okay, now you will see this 30 volt source will be applied across two parallel branches. First branch will form by this 5 ohm and this 25 ohm resistor, and second branch will be formed by this 40, 60 and this 20 ohm resistor. That means 30 volt will be dropped across this 40, 60 and this 20 ohm resistor. Therefore if I apply voltage divider rule to calculate the VTH prime will be equal to 60 divided by the sum of these resistors, 40 plus 60 plus 20, and multiply this fraction with 30. Therefore I will get 60 by 120 into 30, which will give us a value of 15 volt. Therefore our VTH prime equal to 15 volt. So I have calculated VTH prime equal to 15 volt. Now I will keep this 1.5 ampere current source active. Therefore I will replace this voltage source with a short circuit. So after replacing the voltage source with a short circuit, our circuit will look like this. Now look at this terminal and this terminal. Here you will see, with respect to this terminal and this terminal, this 5 ohm resistor and this 25 ohm resistor will be connected in parallel. Therefore I can replace them with a single resistance, and that resistance will be equal to 5 into 25 divided by 5 plus 25, which will be equal to 125 divided by 30, equal to 4.17 ohm resistor. After replacing the 5 ohm and 25 ohm resistor, because they were in parallel, therefore I will get a circuit like this. Now this is our source current. Let's say the source is supplying a total current I here, and it will divide into two portions. One will go in this direction and another will go in this direction. The portion that will be going in this direction will be our I1, and the portion that will be going to this direction will be our I2. Since this I1 will return through this path, this I2 will return through this way, and I1 and I2 will combine, and therefore it will be equal to our I. Now I have to calculate the current that is flowing through this branch. To calculate our VTH double prime, how do we calculate VTH double prime? I will take the current that is flowing through this 60 ohm resistor, and that will be our I1 into the value of that resistor. See, this terminal will be positive and this terminal will be negative. Therefore this terminal and this terminal will get the same polarity. Now see, if I want to calculate this I1, I will calculate I1. I will take the branch resistance of opposite branch. See, this branch has a resistance of 40 ohm. In the denominator I will take the sum of all branch resistors. Take the sum of this 40, this 60 and this 20 ohm resistor. 40 plus 60 plus 20 ohm, and multiply this fraction with the value of total current, the current that is entering at this terminal, equal to 1.5 ampere. Therefore I will get a current of 0.5 ampere. See, our I1 will be 0.5 ampere into 60, so I will get 30 volt. Our VTH prime was 15 volt and VTH double prime was 30 volt. Therefore, as they have the same polarity, therefore I will add them up. Our VTH will be equal to VTH prime plus VTH double prime, which will be equal to 15 plus 30 equal to 45 volt. Therefore this will be our Thevenin equivalent circuit across this A and B terminal for the given circuit. Now let me run a simulation to show our RTH and VTH of the given circuit. See, I have connected a multimeter between A and B terminal, and I have shown the circuit as I have set for our RTH. See, here our RTH equal to 30 ohm, and here our VTH will be equal to 45 volt. And see, in my circuit I have obtained VTH equal to 45 volt and RTH equal to 30 ohm. That means my circuit analysis is completely okay. That's it. Thank you.